Welcome to myprojectbazaar.com. Let we discuss about the process visual voice activity detection as a help for speech source separation from convolutive mixtures. Let me see the abstract of the process visual voice activity detection as a help for speech source separation from convoluted mixtures. Video signals contains both audios and images. The separation of the frames and audios can be useful in many processes. The speech detection can be done on video by analyzing the audio signals from it. The analysis of the audio signals can be done in many ways, such as finding the amplitude and detecting the maximum peaks in the signals. The analysis of the signals can be done by feature extraction approach. The features based approaches can be more reliable for the analysis of the signals since they are not affected by the external disturbances. The process of the identification of the speech in the video is done by employing the feature extraction methods. The feature extraction methods calculates the values from the voice signals to detect the voice activity in the frames. The frames at which the speech is detected is identified. The difference between the feature values were extracted from the frames. The energy and the zero crossing rate is obtained as the features. The differences between the energy of the two frames will be zero if there is no speech is present in the particular frames. The video frames at which the speech occurred can be identified. Based on that, classification can be done. The input video is loaded. Loading input video refers to the identification of the number of the frames in the video, size of the frames, height and width of the frames. The video is converted into frames and voice signals. Here the voice signals depicts the obtained pixel values in the images. The face and the mouth regions were detected from the frames based on Vilogens detection, which is defaultly available in MATLAB 2013. The faces and the mouth detection gives the initial point and the length and the breadth of the face and the mouth regions in the images. The features were extracted from the voice signals. The energy and the zero crossing rate were extracted as the features. The energy and the zero crossing rate were more reliable for audio systems. The difference between the extracted features from the frames were calculated. So the calculation of the zeros and ones, where is the binary decision that producing whether the input frame contains speech or non-speech is obtained, and it is calculated. Let me see the flow of the process. In this process, the input is the video. So here the video is got and it is loaded. After loading the video is converted into frames and voice. Here the voice represents the plotting of the video pixels obtained. So the obtained frames were then pre-processed. So here in the pre-processing step, basic steps like resizing and if necessary gray conversion may be applied. If necessary, maybe gray conversion is applied, else the gray conversion is not applied. And after that, the any one of the filters were employed for the identification of the smoothing of the overall frames in the videos. After that, in the frames, the face regions and the mouth regions were detected. Here this is used for the identification of the voices and movements in the particular positions of the videos. That is like if we talk means the regions in the mouth were differ, so based on that the calculations can be calculated. So for that the mouth detection and the face detection is got, and after that in the voices regions updates the features extracted based on the energy and the zero crossing rate. Here the energy and the zero crossing rate depicts the statistical parameters of the obtained pixel values. The energy will be the same if there is no speech detector in the regions, and there is be differences if there is speech in the region. So based on that, if there is differences, when we provide a decision 1, and if there is no differences, we provide a decision 0. So this is used to build the decision tree. So here the decision tree is just the representation of the frames based on speech and no speech, just the display process. So based on the decision tree, the speech and the no speech is identified and it is depicted in the videos. Let me see the running procedure of the process. If you want to run the code, select the file main.m, which is located in the source code folder. We have done this process in MATLAB 2013 version, so please run the process in MATLAB 2013 version only. So, and also we have given some videos in the dataset. The process will work for the videos which is provided in the datasets. So first select the file main.m in the source code folder, right click it and click on run. You will get the process started. So as we can see, first initially we have given some two videos. We can select any one of the videos from this. So the video will be loaded and the result will be displayed here. Now the video is loading. After the video has been loaded, the video is played. So if we want to play means we can do that. So then the generated audio signals, that is the pixels informations in the frames were plotted as the signals, and then the frame conversion process is applied, so the video is converted into frames. Then after that, the next process is the identification of the faces and mouth regions in the video frames. So here we are identifying the face and the mouth regions in the video frames. So as we can see, in the continuous frames the face and mouth regions is identified, and for some frames the mouth regions were detected wrongly, so that is the error rate that we are measuring. So this process goes on. So for like that, for some frames the mouth regions will be detected wrongly. After that, the plot of the zero crossing rate and the energy, and the plot of the in original signal and the zero cross. So as we can see, this is the both of the plots. So the signal and its energy is plotted, and here like that the zero crossing rate and the original signal is plotted, and based on that the calculations were estimated and the features values were saved based on this extracted values. So after the identification of the zero crossing rate and the energy identification, so here we made the decision. So for each frames the deductions of these were calculated, whether it is speech or not. This is just depiction, just drawing of the whether the frames contains speeches or not, like that. So as we can see that frame 12 contains some speeches, 12 and 13, so other frames were no speeches. So like that the process goes on. This process will take some time for the execution. After the decisions of the process has been made, the detection of the mouth region and the face region is obtained. So as we can see, the mouths and the face regions in the images were got, and while detecting the mouth regions, we are dividing it into four so that we get the corners of the depicted pixels that we got. So and for that the regions were selected and the processing done, and finally this is the final decision that we are going to make. So in this decision the energy and zero crossing rate is obtained. So like that previously told, it is all just a representation of the overall procedure. So as we can see, the speech detected and the non-speech regions were depicted, and based on that the process is executed, and this process goes on. This will take some time for running. So as we can see, first the energy is obtained, and based on that the zero crossing rate is divided, and if the speech is depicted means it is given as minus ones or ones, and there is speeches means like that the depictions were provided in for all the frames in this. So after extraction of the decisions were all got for each frames. Then after that we have to select the train feature. Here the train feature refers, so we have given two videos. So for the two videos the feature values are extracted and they were saved in this. This is used for measuring the performances. Then the test feature means the feature of the input video that we have given. So here we are calculating the performances based on the accuracy, precisions, and the confusion matrices, like that. So this is the decision values for both of the frames that is presented in the video. So this is the test video decision. So here the decision refers to for which frames the speeches were detected and for which frames the speeches were not detected, like that. And so these are all were obtained for each. This is the confusion matrix which is used for measuring the overall performances of the process. And finally we have measured the accuracy, precision, and recall. These values were tabulated as well as, and they were depicted as a graphical form. So thus we have analyzed the speech signals from the videos based on the pixels regions obtained, and using that the performances of the whole process is got. Thank you.